All right, let's dive into an absolutely wild scientific detective story. This is all about proving that you, yes you, can actually find little pieces of ancient, long-dead stars right here on our planet. It is one of the most incredible tales of cosmic discovery, so let's get right into it.
So let me just start with a question, and it's a big one. Do you think it's possible to hold a physical piece of a star that lived and shined and died billions of years before our own sun even existed? I mean, it sounds like something straight out of science fiction, right?
Well, believe it or not, the answer is a definite yes. It's a fact. We know for sure that ancient stardust is here, on Earth. And it's all thanks to some incredibly clever science and a very, very special rock that fell out of the sky. This is the story of how they found it.
Okay, so our investigation, it really begins with this perfect little time capsule, an object that literally traveled through space for billions of years before landing right here. So let's meet the main character in our story, the Murray meteorite. Now, this is not just any old space rock. The Murray meteorite is a special type called a carbonaceous chondrite. You can think of it like a kind of cosmic scrapbook. It's so primitive that it trapped all sorts of materials from the very beginning of our solar system, and, as scientists were hoping, maybe even stuff from before our solar system. And inside this cosmic scrapbook, scientists were on the hunt for something very specific, pre-solar grains. I mean, the name pretty much says it all. These aren't just bits of stars. They're tiny, solid particles that actually formed in the atmospheres of stars that lived and died long before our sun was even a flicker. This is, quite literally, stardust.
But finding these things, it's an unbelievable challenge. I mean, we are talking about searching for microscopic particles inside a rock. It's the ultimate needle in a haystack problem, except the haystack is a meteorite, and the needle is older than our entire solar system. No big deal, right?
So how in the world did they do it? This is where the brilliant chemistry comes in. First, you take a piece of the meteorite and you crush it. Then, and this is the wild part, you dissolve it in a cocktail of incredibly powerful acids. But the goal here isn't to destroy everything. It's actually the opposite. The idea is to dissolve all the common stuff, all the minerals from our solar system, leaving behind only the toughest, most resistant bits. The bits they were betting came from another star. And it worked. After dissolving almost everything else, this is what was left. What you're looking at right here is a single grain of silicon carbide, blown up thousands of times. That tiny, resilient speck is a physical piece of another star that survived an unbelievable journey through space and time to get to us. And they didn't just find one kind. These are actual images from the original 1987 discovery. You can see on the left, there's this little cluster of fine-grained stardust all clumped together. And on the right, you've got a single, more perfectly formed crystal. Every single one is a tiny messenger from a star that's long gone. Now, just to give you a sense of scale here, we are talking about something impossibly small. A typical grain is about 1 micrometer across. That is over 100 times smaller than a single grain of fine sand. It's a universe of history packed into a speck you can't even see. So, okay, they found these tiny, super tough grains. But how could they be absolutely sure they were pre-solar? How did they know they came from outside our solar system? Well, for that, they needed a kind of cosmic fingerprint. And guess what? They found it. The smoking gun is all in the chemistry. See, everything that formed in our solar system, from you and me to the rocks on Mars to Jupiter, it all shares a standard recipe of atoms, what we call isotopes. But these grains, they were completely different. Their isotopic ratios were, and I'm quoting the original paper here, highly anomalous. They just didn't match our solar system's recipe at all. This was the chemical fingerprint of an alien. First up, they used a technique called Raman spectroscopy. You can basically think of it like a chemical scanner. The analysis shot back this super clear peak you see here, which was a perfect match for silicon carbide. So that's lock number 1. They knew exactly what the material was. The evidence was just so strong that the scientists themselves, in their paper, put it this way. This work is thus the first unambiguous identification of pre-solar sick in meteorites. Unambiguous. That's a powerful word in science. But to make their case totally airtight, they needed one more piece of proof.
So for the final, irrefutable proof, they went one step further. They used something called electron diffraction to look at the grain's physical structure. This pattern of dots confirmed its crystal lattice was cubic silicon carbide. So now they knew what it was made of and its exact atomic structure. Case closed.
So we found stardust. That's amazing. But what does it actually teach us? Why is it such a big deal that we can hold these ancient grains in a lab on Earth?
Well, just think for a second about the incredible life story of this one tiny piece of dust. It formed in the atmosphere of some ancient, carbon-rich star. It survived the death of that star, floated through deep space for who knows how long, got swept up in the giant cloud that eventually became our solar system, somehow survived that violent process, and then finally got trapped inside an asteroid that eventually fell to Earth. It's just staggering.
And that brings us to the biggest takeaway of all. We no longer have to just look at distant stars through telescopes. We now have actual physical samples of those stars that we can hold and study right here in our labs. We can learn about the physics of a star that died billions of years ago by analyzing a single grain of dust that it left behind.
You know, we always hear that phrase, we are made of stardust. A discovery like this makes that idea breathtakingly real. It proves that the history of our entire cosmos isn't just out there in the dark, it's right here, locked inside rocks, falling from the sky. And it really makes you wonder, right? If one single invisible speck of dust can tell us the story of a lost star, what other secrets are just waiting for us to find?